Picture this. Your 11-year-old asks Alexa to play their favorite song, then turns to you and asks, "How does she know what I'm saying?" That question right there is your opening. AI isn't some abstract concept anymore. It's in their phones, their games, their homes. And the right learning kits let them build the systems behind the magic instead of just consuming it. I'm Chloe Miller, and after testing dozens of these platforms over the past 2 years in my workshop, I've learned exactly what separates the tools that actually teach machine learning from the ones that just put on a good show.
You're listening to the STEM Lab podcast. Before we go any further, just a quick heads up. Everything you're about to hear, the research, the testing, the writing, that's all done and verified by real people. But the voice you're hearing right now, that's AI generated. We think it's important you know that up front. Anyway, if you've been listening for a while, thank you. Seriously, it means a lot that you keep coming back. And if you're new here, welcome to the show. We drop new episodes every Monday, Wednesday, and Friday, covering STEM learning tools, experiments, and projects that actually work. Today, we're talking about AI learning kits for kids, what's worth buying, what's worth skipping, and how to pick the right one for where your kid is right now. Let's jump in. After working alongside solar controllers and hydroponics automation that use similar machine learning principles, I've found that the right AI kit transforms kids from users into creators, teaching them to train models, recognize patterns, and understand the ethical weight of algorithmic decisions. Here's my quick verdict. The best AI learning kits bridge visual programming and real-world robotics, support progressive skill paths from supervised learning demos to custom neural network training, and prepare kids for Python-based machine learning workflows used in actual data science careers. Now, let's talk about what to look for when you're choosing one of these kits. You need kits that support progressive language transitions, block-based interfaces for foundational logic like Scratch or Blockly, then Python for actual machine learning libraries. Look for platforms compatible with industry-standard frameworks like TensorFlow Lite, scikit-learn, or PyTorch. The kit should work offline for core activities, meaning no cloud dependency for basic model training, but offer cloud integration for larger datasets when kids are ready. Check operating system requirements carefully. Many AI kits lean heavily on Chromebook or iPad apps with limited desktop support, which can bottleneck kids when they're ready for Jupyter notebooks or VS Code. The best platforms run on Windows, Mac OS, and Linux, with clear documentation for library installation. I've watched too many promising young engineers hit a wall when their so-called AI kit turned out to be a proprietary app with no export pathway to real Python environments. Pay attention to expandability. Can the kit interface with Arduino, Raspberry Pi, or other microcontrollers? The transition from a closed ecosystem to open-source hardware is where genuine career skills begin. A kit that teaches AI in isolation is a toy. One that lets kids deploy trained models to robots, sensors, or home automation systems is a skill-building investment. Age ranges are useless without skill milestones. For ages 8 to 10, look for kits that teach pattern recognition, classification, and supervised learning concepts through visual interfaces. Kids should be able to train an image classifier or voice command system without touching code. By ages 11 to 13, they should be writing Python scripts to pre-process data, adjust hyperparameters, and evaluate model accuracy. Ages 14 and up need kits that introduce neural network architecture, unsupervised learning, and ethical AI considerations like bias in training data.
The best AI learning kits also differentiate between demonstrating AI and building AI. A robot that uses AI to follow a line is fine for beginners, but it's not teaching machine learning, it's teaching sensor logic. True AI kits let kids create training datasets, label examples, run training cycles, and test model performance. That's the difference between watching a magic trick and learning to perform it. AI model training is computationally intensive. Kits that run entirely on low-power microcontrollers like basic Arduino boards can't handle real machine learning workloads. They're simulating AI, not training it. Look for kits with onboard processors capable of running TensorFlow Lite models, things like ARM Cortex chips, Raspberry Pi 4 or 5 or equivalent, or clear instructions for offloading training to a connected computer. Check connectivity requirements. Does the kit need constant Wi-Fi for cloud processing, or can it train models locally? USB-C power delivery is increasingly standard and future-proofs the investment. Battery operation matters if kids want to deploy their AI robots in the field. I have literally had students build wildlife camera classifiers for backyard ecology projects. Durability for repeated use is non-negotiable. Look for reinforced connectors, modular components that survive dozens of assembly cycles, and replaceable sensors. Cheap servo motors burn out. Fragile camera modules crack. The best kits use industrial-grade components that tolerate the chaos of a home STEM lab. I've seen $200 kits die after 3 projects, and $150 kits still running strong 2 years later. Reviews and user forums reveal the truth faster than marketing copy. Some AI kits require monthly platform subscriptions for cloud training, model storage, or access to curriculum. Others are one-time purchases with lifetime access to open-source tools. Be brutally honest about long-term costs. A $120 kit with a $15 a month subscription becomes a $300 investment in year 1. Check whether the kit requires proprietary consumables, custom sensors, batteries, or expansion modules that lock you into a single vendor. The best platforms use standard components, USB cameras, I2C sensors, and GPIO-compatible peripherals you can source anywhere. I've built AI vision systems with Raspberry Pi cameras that cost a fraction of branded alternatives and perform identically. Also consider curriculum sustainability. Does the company provide ongoing project updates, or will the platform stagnate in 2 years? Open source ecosystems like those built on Python and Raspberry Pi have global communities publishing new AI projects daily. Proprietary platforms live and die by corporate roadmaps. Choose tools that your kids will still be using and expanding when they're in college. This matters. The best AI learning kits for kids explicitly teach bias recognition, data privacy, and algorithmic accountability. Look for curriculum that asks kids to question their training data. Is the dataset representative? What happens if the model makes a mistake? Who benefits from this automation, and who might be harmed? From a sustainability lens, check power consumption and material sourcing. Some kits use recycled plastics and low-power components. Others are e-waste waiting to happen. I prioritize kits with upgradable, repairable designs over disposable all-in-one units. A modular platform that grows with your child for 5 years beats a flashy gadget that's obsolete in 18 months. All right, let's get into my top picks. The DF Robot Husky Lens AI Vision Sensor Kit combines a compact camera module with onboard machine learning processing, letting kids train object recognition, face detection, and line-following models without needing a separate computer for inference. Check the link below to see the current price. It connects via I2C or UART to Arduino, Raspberry Pi, or microbit platforms, making it a versatile bridge between visual AI concepts and embedded robotics projects. You train models using the built-in screen and button interface, then deploy them instantly. No code required for basic tasks, but full Python and Arduino IDE support when they're ready to customize. Here's what matters about the specs. It runs on 3.3 to 5-volt power from USB or battery, has an ARM Cortex M7 processor for onboard model inference, and trains and runs entirely offline with no cloud dependency. Durability is solid. The lens housing withstands drops, and the connectors are reinforced. On the plus side, onboard training and inference mean no laptop needed for basic AI projects. It works with industry-standard platforms like Arduino, Raspberry Pi, and microbit. It has 7 built-in AI functions, including face recognition, object tracking, color recognition, tag recognition, object classification, line following, and QR code reading. Kids see real-time model performance and can iterate quickly, and the open-source firmware allows advanced customization as skills progress. The downsides: the button-only interface for labeling training data is tedious for large datasets.
Display resolution limits detailed visual feedback during complex tasks. There's no built-in battery, so you need an external power source for mobile deployments. And the documentation assumes familiarity with I2C protocols, which can confuse beginners. For skill outcomes, ages 10 to 14 can master supervised learning workflows, dataset creation, and real-time model evaluation. By Project 5, kids should be deploying custom object classifiers to Arduino robots and understanding the trade-off between model accuracy and inference speed. This prepares learners for computer vision roles in robotics and autonomous systems.
Next up, the NVIDIA Jetson Nano Developer Kit is a genuine industry-standard platform. Check the link below to see the current price. This is the same hardware used in commercial drones, warehouse robots, and edge AI deployments. It runs full Ubuntu Linux and supports TensorFlow, PyTorch, and other professional machine learning frameworks, giving kids access to the exact tools they'll use in data science internships and university research labs. You'll need to provide your own micro SD card, power supply, and peripherals like keyboard, mouse, and camera, but that's part of the value. Kids learn to build a complete AI workstation from components. For specs, it's got a quad-core ARM A57 CPU, 128-core NVIDIA Maxwell GPU, 4 gigs of RAM, and it requires a 5-volt, 4-amp barrel jack power supply because USB power isn't sufficient for GPU tasks. It runs Ubuntu with Jetpack SDK, which includes CUDA, CUDNN, and TensorRT. It's fully offline capable once software is installed, and the passive cooling handles sustained loads without throttling. The pros: industry-standard hardware and software means skills transfer directly to professional environments, full GPU acceleration for training and running complex neural networks, extensive community support and project libraries on GitHub and NVIDIA forums. It can run multiple camera inputs and real-time vision pipelines simultaneously. And it's expandable with standard peripherals, no proprietary lock-in. The cons: steep learning curve. It requires Linux familiarity and command line comfort. No included curriculum or guided projects, so parents need to source learning materials. The power supply and micro SD card add $40 to $50 to the initial cost. And this setup process, flashing the operating system, installing dependencies, takes 2 to 3 hours and can frustrate younger learners. Best for ages 14 and up with prior Python experience. By Project 3, kids should be training custom image classifiers with their own datasets and deploying models for real-time inference. By Project 10, they'll understand model optimization, edge deployment constraints, and GPU memory management, skills directly applicable to AI engineering careers. This is the platform that bridges hobbyist projects and professional portfolios. The Raspberry Pi AI Kit with Halo 8L module brings hardware-accelerated neural network processing to the Raspberry Pi 5. Check the link below to see the current price. It delivers up to 13 trillion operations per second for running large vision models in real time. This is the kit for kids ready to deploy YOLO object detection, semantic segmentation, or pose estimation models without the latency of cloud APIs. It plugs directly into the Pi 5's PCIe slot and integrates seamlessly with standard Python machine learning libraries, no exotic toolchains or proprietary software. The important specs: the Halo 8L AI Accelerator module delivers 13 TOPS INT8 performance through a PCIe Gen 3 interface, but it's only compatible with Raspberry Pi 5, not earlier models. Power draw is modest at 2 to 4 watts under load, so standard USB-C power supplies work fine. The software stock is fully open source with Python bindings, and it can process 1080p video streams at 30+ frames per second for object detection with no cloud dependency. The advantage is it transforms Raspberry Pi 5 into a legitimate edge AI platform, runs production-grade models like MobileNet, ResNet, and Efficient Det at usable speeds, fully open-source software with active community development, low power consumption compared to discrete GPU solutions, and kids learn model quantization, optimization, and edge deployment. skills critical for IoT AI careers. The disadvantages: only compatible with Raspberry Pi 5, which was released late 2023, adding $60 to $80 to total system cost if you don't already own one. Driver installation and model conversion require command line work and aren't beginner-friendly. Limited official curriculum means parents need to adapt existing Pi projects or write their own, and Halo's model zoo is smaller than TensorFlow Lite's, so some niche models require manual conversion. Ages 13 to 16 with intermediate Python skills can build real-time vision systems within 2 weeks. By Project 5, kids should understand model quantization, INT8 versus FP16, throughput versus latency trade-offs, and how to profile inference performance. This kit is preparation for embedded AI roles, exactly the skill set needed for robotics startups and hardware companies. The Anki Cosmo robot with CodeLab is the most approachable AI robotics kit for younger learners. Check the link below to see the current price. It looks like a Pixar character and behaves like one, using facial recognition, emotion simulation, and pathfinding to interact with kids naturally. You program Cosmo using a visual block-based interface called CodeLab, built on Scratch blocks, or graduate to the Cosmo Python SDK for text-based control. The robot uses its built-in camera and onboard processing to recognize faces, navigate environments, and respond to voice commands, teaching kids how perception, decision-making, and actuation layers work together in AI systems. The specs that matter: onboard ARM Cortex processor, camera with 30 frames per second processing, 3 motorized power cubes for interactive games, rechargeable battery with 90 minutes per charge. It requires an iOS or Android device or a Windows or Mac computer for the programming interface. Bluetooth LE connectivity means no Wi-Fi required, and it's durable enough for repeated drops. I've seen Cosmos survive toddler attacks and keep running. The pros: engaging personality makes abstract AI concepts concrete and relatable. Dual learning path with visual blocks for beginners and Python SDK for advanced learners. Facial recognition and pathfinding demonstrate real computer vision and navigation algorithms. No cloud dependency. Everything runs locally on the robot. And there's extensive community-created projects and lesson plans available free online. The cons: Anki went bankrupt in 2019. Digital Dream Labs acquired the brand, but software support is inconsistent. The CodeLab app occasionally bugs out on newer iOS and Android versions. The Python SDK documentation assumes intermediate programming skills, which is a steep jump from blocks. And battery life degrades after 12 to 18 months of heavy use. Replacement is possible, but requires soldering. Ages 8 to 12 learn supervised learning through training facial recognition, state machines by programming behaviors, and sensor fusion by combining camera and accelerometer data. By Project 10, kids should be writing Python scripts to control Cosmo autonomously and understand how perception loops drive robotic decision-making. This builds foundation for ROS, Robot Operating System, and autonomous vehicle programming. The Pico Fusion AI camera module with Edge Impulse integration pairs a low-cost RP2040-based microcontroller with a 2-megapixel camera and direct integration with Edge Impulse's cloud-based machine learning training platform. Check the link below to see the current price. Kids capture training images directly on the device, upload datasets to Edge Impulse, train models using neural architecture search, then deploy optimized firmware back to the Pico Fusion for real-time inference, all without writing a line of TensorFlow code. It's a full machine learning lifecycle in a $45 package. The key specs: Raspberry Pi RP2040 dual-core ARM Cortex-M0 Plus processor running at 133 MHz, 2-megapixel camera module, onboard LED ring for visual feedback, USB-C for power and data. It requires an Edge Impulse account. The free tier supports unlimited public projects. It's cloud-dependent for model training, but runs inference offline once firmware is deployed. The plastic housing is adequate, but not reinforced, so treat it gently. The pros:
Edge Impulse's Visual Machine Learning Studio teaches the full training pipeline without code. Fast iteration cycles. You can capture data, train a model, and deploy firmware in under an hour. Neural Architecture Search automatically optimizes model size and accuracy for constrained hardware. The free tier is genuinely useful. Paid features aren't required for educational projects. And it exposes kids to embedded machine learning workflows used in IoT and wearable devices. The cons. Cloud dependency for training means no internet equals no new models, though offline inference works fine. Edge Impulse's free tier limits dataset storage to 30 minutes of video or 200 megabytes of images. The RP2040's processing power is limited. It can't run large models. You're stuck with lightweight architectures. And documentation assumes familiarity with embedded development, so the setup process is poorly explained for beginners. Ages 11 to 15 learn dataset curation, labeling best practices, confusion matrix interpretation, and embedded deployment workflows. By Project 5, kids understand why model size matters due to flash memory constraints, how quantization affects accuracy, and how to profile inference latency. This prepares learners for tiny ML roles, an emerging field deploying AI to battery-powered sensors and edge devices. The Aliga Smart Robot Car Kit V4 with AI Vision combines Arduino-compatible robotics with a Raspberry Pi camera module. Check the link below to see the current price. It lets kids build autonomous navigation systems using both traditional sensor logic, like ultrasonic and line following, and computer vision using OpenCV-based object detection. It's a hybrid platform. Arduino Uno manages motors and sensors, while a Raspberry Pi 4 handles vision processing, teaching kids how distributed systems and task allocation work in real-world robotics. The important specs: Arduino Uno R3 board, dual H-bridge motor driver, Raspberry Pi 4 with 2 gigs minimum, which isn't included, camera module with servo-controlled pan and tilt mount, ultrasonic sensor, line tracking module, and an 18650 battery pack. It requires Arduino IDE and Raspberry Pi OS with full Python and C++ support. It's offline capable when software is installed. The acrylic chassis is sturdy, aluminum motor mounts reduce vibration, and the modular design makes component replacement easy. The pros: dual controller architecture teaches realistic robotic system design with high-level processing on Pi and low-level control on Arduino. Includes both traditional sensors and camera, so kids compare rule-based and machine learning-based approaches. Extensive documentation with 30+ projects, from basic line following to TensorFlow Lite object tracking. Standard components mean easy expansion. You can add LiDAR, IMU, GPS, or custom sensors using I2C or SPI. And there's strong community support with hundreds of user-contributed projects on forums and GitHub. The cons: Raspberry Pi 4 not included adds $50 to $80 to total cost, depending on RAM size. Assembly takes 4 to 6 hours, with dense, occasionally ambiguous instructions. The camera servo mount is wobbly and needs tightening with thread locker to prevent drift during operation, and battery life is only 45 to 60 minutes under continuous use, so you need multiple 18650 cells or an external USB battery. Ages 12 to 16 learn sensor fusion, distributed computing, motor control algorithms like PID loops, and OpenCV basics. By Project 15, kids should be deploying custom TensorFlow Lite models for object tracking and understand the latency and bandwidth trade-offs of split processing architectures. This prepares learners for ROS workflows, autonomous vehicle projects, and competition robotics like FIRST Robotics or VexU. Now let's cover some frequently asked questions. Kids can start exploring AI concepts as early as age 8, with visual programming platforms that teach supervised learning through hands-on activities, training a robot to recognize objects or sort images by category, but they won't understand the underlying math. By ages 11 to 13, they're ready for introductory Python and can grasp how training data, labels, and model parameters interact to improve accuracy. The goal at younger ages isn't to explain backpropagation or gradient descent. It's to build intuition about pattern recognition, trial and error optimization, and the idea that machines learn from examples rather than following fixed instructions. The best AI learning kits scaffold these concepts progressively, starting with playful demonstrations and advancing toward real model training workflows. You'll know they're ready for the next tier when they start asking questions about why a model made a specific prediction or how they could improve its performance. It depends on whether the kit offloads computation to the cloud or runs locally. Cloud-based platforms like Edge Impulse, Teachable Machine, or some app-driven robots work fine on tablets and Chromebooks because training happens on remote servers. Your device is just the interface. Local training kits, like those using Raspberry Pi, Jetson Nano, or Arduino with TensorFlow Lite, need more processing power, a mid-range laptop with at least 8 gigs of RAM, and a modern multi-core processor for comfortable Python development. Tablets hit a wall when kids want to use Jupyter notebooks, install Python libraries, or customize model architectures. Those workflows require full desktop operating systems. The best AI learning kits acknowledge this progression. Start with tablet-friendly visual platforms to teach core concepts, then transition to laptop-based tools as projects grow more complex. If you're building a long-term STEM learning setup, budget for a capable computer. It's the platform for every advanced skill, from CAD design to data science. The honest answer: both kinds exist, and marketing often obscures the difference. AI robots that follow pre-programmed voice commands or sensor logic aren't teaching machine learning. They're teaching conditional statements and sensor input handling, which are valuable skills, but not AI development. Real AI kits let kids create datasets, label training examples, choose or configure model architectures, run training iterations, evaluate accuracy metrics, and deploy models for inference. If the kit's AI is a black box that kids can't inspect, modify, or retrain, it's a demonstration, not a learning tool. The best platforms, like those using TensorFlow Lite, PyTorch, or Edge Impulse, expose the full training loop and use the same libraries employed by professional data scientists, just with kid-friendly interfaces and simplified default settings. By age 14, kids working with legitimate AI kits are writing Python code that would be recognizable, if basic, in a university machine learning course or industry internship. The question isn't whether the kit is simplified, all education simplifies, but whether it teaches transferable skills using real tools or creates a walled garden that has to be unlearned later. This is a critical blind spot in many products. The best AI learning kits for kids explicitly teach data ethics as part of the curriculum, asking kids to consider who their training data represents, what happens if a model makes a mistake, and whether automating a task might have unintended consequences. Platforms like Edge Impulse, TensorFlow Lite, and local Raspberry Pi setups allow fully offline operation, so training data never leaves your home network. Cloud-based platforms like Teachable Machine or some app-driven robots upload images and training data to company servers. Read the privacy policy and understand data retention policies before letting kids create accounts. Some companies anonymize and aggregate data for research. Others sell it to advertisers. I prioritize kits with transparent, kid-safe data handling and explicit parental controls. Beyond privacy, look for curriculum that addresses algorithmic bias. Have kids intentionally create an unbalanced training set, all faces of one skin tone, for example, and observe how the model performs poorly on underrepresented groups. These lessons, that AI reflects the data it's trained on and that data is never neutral, are as important as learning to write Python. Teaching kids to build AI without teaching them to question it is handing them power tools without safety training. A solid progression looks like this. Ages 8 to 10 start with visual platforms like Scratch-based AI extensions, Teachable Machine, or Cosmo that teach classification, labeling, and supervised learning without code. Kids create small datasets with 20 to 50 examples, train models with one click, and see immediate results, building intuition about how more data and better labels improve accuracy. Ages 11 to 13 transition to block-to-text platforms like CodeLab, MindPlus, or MakeCode with Python Export, where they start reading and modifying auto-generated code. Projects introduce datasets with hundreds of examples, basic hyperparameter tuning like learning rate and epochs, and model evaluation using accuracy and confusion matrices. Ages 14 and up move to full Python environments like Jupyter Notebooks, Raspberry Pi AI Kit, or Jetson Nano using industry-standard libraries. Projects involve data pre-processing like normalization and augmentation, custom model architectures with convolutional layers, dropout and activation functions, and deployment to edge hardware with latency constraints. By age 16 to 17, advanced learners are working with transfer learning, fine-tuning pre-trained models, and exploring unsupervised learning or reinforcement learning. The best AI learning kits explicitly position themselves within this progression. They tell you where kids should start and what comes next. Here's my final take. The best AI learning kits for kids reveal how the systems shaping their world actually work, not through abstraction, but by putting training data and model architectures directly in their hands. Choose platforms that respect the complexity of real machine learning while scaffolding the learning curve. Visual tools for foundational intuition, Python for intermediate control, industry-standard frameworks for career preparation. Prioritize kits that run offline, expand with open-source hardware, and teach ethical reasoning alongside technical skills. Your goal isn't to raise a child who can use AI, everyone will do that, but one who can build it, question it, and deploy it responsibly. Start with the DFR Robot Husky Lens if you need immediate visual results. Graduate to Raspberry Pi AI Kit or Jetson Nano when Python skills solidify, and frame every project around this question. What decisions is the model making, and who gets to decide if they're right? That's the education the next decade demands. And that wraps up this episode of the STEM Lab podcast. Thanks for listening all the way through. I know there were a lot of details in this one. We've got new episodes coming out every Monday, Wednesday, and Friday, so there's always something fresh. If you found this helpful, I'd really appreciate it if you'd leave a 5-star rating and write a quick review. That's honestly the biggest thing that helps other people find the show when they're searching for this kind of content. And while you're at it, hit subscribe or follow so you get notified the second a new episode drops. Thanks again, and I'll catch you in the next one.